Hello everyone again. This is lecture 8 part 3 of wave optics. Let us move on with the final discussions of polarization. After that we will go on with the summary and that will be the end of wave optics. So I am Sameer Lavankar. Let's begin our discussion. So finally right now we are on the polarization concept. Before that we did all the concepts which were involved in the wave optics concept. We started with the introduction concept in which we understood the concept of wave optics, how it is different from the Descartes theory of light. Why was there a need for the wave optics to come into picture? Then in the Huygens principle we understood the concept of wavelength and wavefront. What is the definition of wavefront? What can we find out a wavefront at some time t is equal to tau if we know the wavefront at some time t is equal to 0. Then the reflection and the refraction laws of plane waves using Huygens principle. So in this, using the Huygens principle and the wavefront concept, we proved the refraction and the reflection laws. Then in the coherent and the incoherent addition of waves, we understood the concept of intensity being maximum or minimum. So for coherence it is maximum intensity and for incoherence it is minimum intensity. Then in the interference of light waves in Young's experiment, we understood the application of coherence and incoherence. So why there is a bright fringe, why is there a dark fringe, why at some part difference only a dark fringe is occurring, why at some part difference only bright fringe is occurring, why there is a central bright fringe always, and so on. Then also we learnt about the coherence and incoherence concept. We also understood Doppler effect. Finally we understood what is diffraction, how it is different from interference. Is it a mixture of interference only, is it a superposition of two diffraction patterns we observed in interference of light. Finally we understood. Right now we are on the polarization concept. In the last lecture I explained to you how this polarized concept is being understood, why is there a difference in propagation of transverse wave in either x direction, y direction, z direction, how it is different from unpolarized light, etc. Today we will understand how can we convert an unpolarized light into polarized light. So without any change, let's move on. So these were all the concepts we understood in the last lecture only. So we are assuming that the propagation or displacement is being observed because of the change in the electrical wave signals. So this was the equation also. Then finally let us move on to today's concept here. So now this can easily be so the polarization can be easily demonstrated using a simple Polaroid. So what is a Polaroid? Polaroid is nothing but a device which is used to convert unpolarized light into polarized light. What is the example of an unpolarized light? So if I try to make an example here, so let us suppose this is the passage. So if we pass this unpolarized light, so this is an unpolarized light, and this is a polarized light. So this is an unpolarized light, this is a polarized light, so and this is a Polaroid. So when we pass this unpolarized light through a Polaroid, what we will observe? We will observe polarized light which is converted from one direction to another direction. So if there is a mixture of different transverse waves interacted onto a single frame, then it can be divided, or it can be only and only the thing which is visible is either in y direction or let us say z direction. So it is only and only polarized or converted into single form. So this is the example of Polaroid. So how the mechanism, I explained you the mechanism, what is the thing happening in a Polaroid. So a Polaroid consists of a long chain molecules aligned in a particular direction. The electric vectors associated with the propagating light wave along the direction of aligned molecules get absorbed. So what happens is it just absorbs these electrical signals. So these signals are absorbed when we pass it through a Polaroid, and because on passing only which thing remains is only in one direction. Okay. So the electric vectors associated with the propagating light wave along a direction of aligned molecules get absorbed. Thus if an unpolarized light wave is incident on such a Polaroid, then the light wave will get linearly polarized. What does it mean by linearly polarized? It is only polarized in one linear sense, with the electric vector oscillating along a direction perpendicular to the aligned molecule, the direction which is known as path axis of the Polaroid. So this path axis I will try to explain you in the subsequent slides. For now, just explain this concept, just try to understand this concept, that when we try to pass an unpolarized light through a Polaroid, it will absorb all the electric vectors which are apart from this y polarization. So if we are assuming that we are doing the polarization in y direction, then apart from all the transverse rays which are not a y polarized light will get absorbed, and hence the result which we will observe will be a polarized light as shown in the figure. Thus, if the light from an ordinary source like a sodium lamp passes through a polarized sheet, so it is quite evident that all the ordinary sources are nothing but unpolarized light. So if a light from an ordinary source like a sodium lamp passes through a Polaroid sheet P1, so we are assuming this sheet to be P1, it is observed that its intensity is reduced to half. So this is another concept, again we just need to remember this concept. So let us suppose that the intensity of light, the sodium lamp light, was I or I0, then the intensity of this light after being passed through Polaroid will be I0 by 2. Please remember this concept, it is very important concept. If after the unpolarized light is passed through a Polaroid, the intensity is being reduced to half, that is if it is I0, then it will reduce to I0 by 2. Rotating P1 has no effect on the transmitted beam and transmitted intensity remains constant. So if we try to change this polarity, so let us suppose this is the direction of polarization and now and this is the screen. So it is saying that if we try to change the direction of the screen, will the polarization change? The polarization won't change, it will be always y only, and always there will be polarized light I0 by 2. So the after passes the intensity will be always I0 by 2 only. So rotating P1 has no effect on transmitted beam and the transmitted intensity remains constant. Now let an identical piece of Polaroid P2 be placed before P1. So now they are trying to do is, if there is an example here, so I will try to explain you in next slide only. So this is how it is being done. So let us suppose we are assuming two Polaroids, either in same sense, this is same sense, this is inclined and this is completely 90 degrees. So what will happen if we try to do this scenario? What will be the polarized light? Will the polarized light be visible or it won't be visible? So let us go on there. For now, let me just iterate you the final concluding statement. So as expected, the light from the lamp is reduced in intensity on passing through P2 alone. Quite evident, if we pass the light from having an intensity I through a Polaroid P2, the intensity will be reduced to I0 by 2. But now rotating P1 has a dramatic effect on the light coming from P2. Now if we try to change the orientation of P2, then there may be change, then there may be effect. Why will there be effect? I will try to explain you line by line. For now, just understand this effect, that there will be an effect. In one position, the intensity transmitted by P2 followed by P1 is nearly 0. When turned by 90 degrees from this position, P1 transmits nearly the full intensity emerging from P2. So it is saying that there are some orientations of this sheet P1 for which the intensity or the polarized light which we will get after passing through this P1 will be 0. Maybe the intensity can be 0 also, and maybe the intensity can be the same, which is I0 by 2. When does it happen? When does it take into scenario? I will try to convey to you. For now, you just explain that if only a single sheet is happening, then there will be simple orientation from change from I0 to I0 by 2. It does not depend on the angle of orientation. But if there are two sheets, if there are two sheets being impacted, this is the unpolarized light coming from this scenario and we are finding out the polarized light at this place, then after the passage from first sheet, it will be I0 by 2. But after this, because depending on the orientation of the first, with respect to the first one, the intensity at this position can be either 0, either same, which is I0 by 2, or it can be a change, or it can be in the range of I0 by 2 to 0. What will be its value? We will try to convey in the next subsequent slides. Okay, so now please explain. Let me just look at here. So this is one of the orientation. Let us suppose this to be an angle only. So let us suppose I make a line. So here the angle of inclination was theta equal to 0. So here theta will be 0 degrees, here theta will be 45 degrees, and here theta will be 90 degrees. So now let me first read and then I will try to explain. So the above experiment can be easily understood by assuming that light passing through the Polaroid P2 gets polarized along the path axis of P2. Quite evident that anything which is passing through Polaroid P2 will get polarized. How it will polarize? It depends on the path axis of P2. So if for any scenario we are trying to find out, the value of polarization at some value for which the polarization is always in a z direction. Let us suppose it is always z polarized wave. If the polarized if the polarized light we are getting from the sheet P2 is always a Y polarized light, and the Polaroid which is P1 is always passing the pass axis Z, then anything which passes in Y direction will give you an intensity of 0, because it will only and only pass, because everything of Y direction will get absorbed by this Polaroid which is having a pass axis of Z. Let me try to explain you using the sheet here only. So let us suppose this is your unpolarized light. Let me write the unpolarized light as UL. Now let us suppose this is the sheet P2, and let us suppose this is the sheet P1. Now for example, for our case, let us take the scenario that P2 is a Y passing Y, it has a pass axis of Y. So if it has a pass axis Y, then the polarized light which we will get from this scenario will be of this sequence. Why it is of this sequence? Because anything apart from Y axis, the electrical vectors are being absorbed. Because the electrical vectors are being absorbed, only Y direction remains, hence this is the polarized light which we will get in this scenario. This is, let me write this as PL. Now after this, what will happen is, let us suppose we are taking a scenario in which the pass axis of this Polaroid is Z, then because there is no because anything which is on the left hand side of P1 does not have a electrical vector which is propagating in the Z direction, therefore there will be no intensity here, because everything from this Y direction polarized light will be absorbed, hence there is no light being formed here, hence the intensity will be 0 in this case. If we take another scenario, in which the pass axis here was Y. So if the pass axis here was Y, then we will get the same thing which is this. So this was the concept which I was trying to convey to you. So if the pass axis of P2 makes an angle theta with the pass axis of P1, then when the polarized beam passes through the Polaroid P2, the component E cos theta will pass through P2. So this is the same thing. Let me try to explain using the explanation here. So let us suppose we are trying to make a scenario in which where should I write? Let me explain it here. So let us suppose this is one of the unpolarized light. So this is an unpolarized light. Let us say this is the Polaroid. Let us say this is only the Polaroid P. Now when we are trying to pass through this scenario which is having a pass axis of Y, then two things can come into picture. Some people can say, because there is no Y direction propagation, there is no electrical vector in Y direction, in any case scenario, hence the intensity would be 0, but this is not correct. What will happen is, this unpolarized light we can convert this into, we can just change it to components, and then we can find out this unpolarized light will have a component in the X direction and Y direction. So if I try to convey it like this, so let us suppose this is Y and this is X. So this is nothing but if we try to change its components. So let us suppose this is Y axis, let us say this is theta here, then and this is E here, then the propagation or the convention we can change it to E cos theta and E sin theta. That is the concept being told here, and hence this both are proportional, and hence we can finally find out a Y polarized light here. So this was this was the concept which was taught to you in the second point here, that if the pass axis of P2 makes an angle theta with the pass axis of P1, so this is being told in this. Let us suppose this is that concept, this is that concept, that this is an angle, this is making an angle. Let us suppose this is that angle theta here. Then what will pass through it? Only the component E cos theta will pass through P2. Thus, as we rotate the Polaroid P1 or P2, the intensity will vary as I is equal to I naught cos square theta. So this was the final concept. You just need to remember this, that when we are trying to find out the value of intensity depending on the initial intensity, let the initial intensity be I naught, and we are finding out the value of intensity after the passage is being done from two Polaroids, as long as we know the intensity, then the intensity will be equal to I is equal to I naught cos square theta, where I naught is the intensity of the polarized light after passing through P1. Please make sure that it is the intensity after passing through point P1. This is known as Mellus law. The above, please remember this also, that this is known as Mellus law, because in exams this can come into picture, that define Mellus law, tell its assumptions and so on. The above discussion shows that the intensity coming out of a single Polaroid is half of the incident intensity. This was being explained to you in the previous concept only, that whenever there is a passage of unpolarized light through a Polaroid, the polarized light will have an intensity which is half of the previous intensity. By putting a second Polaroid, the intensity can be further controlled from 50% to 0. So as I already explained to you, that when we pass the polarized light through two sets of Polaroid, then the intensity can vary from 0 to 50%. When will it be 0? When the polarization axis is being changed. Let us say the polarization axis for first was y and the pass axis for second was z. Then in this direction the intensity in the final screen or final thing will be 0. So the intensity can be further controlled from 50% to 0 of the incident intensity by adjusting the angle between the pass axis of two Polaroids. The Polaroids can be used to control the intensity in sunglasses, window panes, etc. So we can use it in the examples of sunglasses, window panes, etc. Polaroids are also used in photographic camera and 3D movie cameras. So these are some of the examples of or applications of where the Polaroid is being used. Okay, so now let us move on to one of the questions for this intensity concept of how it will change for two different scenarios, two different Polaroids. So discuss the intensity of transmitted light when a Polaroid sheet is rotated between two crossed Polaroids. So please look over the solution here. So let I naught be the intensity of polarized light after passing through first Polaroid P1. So let us suppose this is the Polaroid P1 and this is the Polaroid P2. Then we are assuming that the intensity I naught is nothing but after Polaroid P1. So let us say this is that intensity being talked about here. Let us, this is the intensity I naught, that means that the intensity here was 2 I naught. Okay, then the intensity of light after passing the second Polaroid will be, it depends on a function of theta, which will be equal to I naught cos square theta, where theta is the angle between the pass axis of P1 and P2. So as you can see, quite evident that the value of theta can vary between 0 to 90 degrees. So we know that for cos 0 it is 1 and for value of cos 90 it will be 0. Where theta is the angle between pass axis of P1 and P2. Since P1 and P3 are crossed, the angle between the pass axis of P2 and P3 will be pi by 2 minus theta, quite evident. Therefore, hence the intensity of this will be P2 here, I guess. Hence the intensity of light emerging from P3 will be I is equal to I naught cos square theta multiplied by cos square into pi by 2 minus theta. So what it is saying is, if you are assuming a P3 here which is being crossed, so the angle difference between both of them will be pi by 2 minus theta, assuming that the theta is the difference between the P1 and P2. So if the angle difference between P1 and P2 is theta, then the angle difference between P2 and P3 will be pi by 2 minus theta. So this was the explanation being talked about here. Hence so this is nothing but the example of two crossed Polaroids. Because what does cross means? Cross means they are at 90 degrees angles. Hence the intensity of light emerging from P3 will be I is equal to I naught cos square theta multiplied by cos square pi by 2 minus theta. So just simple mathematical calculation will give you I naught by 4 sin square 2 theta. Therefore the transmitted intensity will be maximum when theta is equal to pi by 4. So when it will be maximum, when the theta value will be pi by 4, at that value it will be 1 and hence you will get the intensity maximum which will be equal to I naught by 4. So this was one of the example I need to convey to you. That is, so till now what we understood is, when we try to when there is a single Polaroid, then first of all, what is the use of Polaroid? Polaroid is used to convert an unpolarized light into polarized light. Now going to the intensity concept. So the intensity before passing through the Polaroid, let us say if it is I, then after polarization it will be I naught by 2. Now let us move if there is two Polaroids, then let us suppose the intensity first was 2 I naught. After the first polarization it will be changed into I naught. After this, the intensity which is processed after the second Polaroid depends on the angle which the first and second Polaroid are making. If it is inclined at an angle theta, then the intensity observed will be equal to I naught cos square theta. Now if we are taking 3 Polaroids, then after the intensity the third Polaroid will depend on I naught cos square theta multiplied by the angle between second and third Polaroid. So this is the complete discussion of intensity portion and Polaroid portion. After this, in the next lecture, let me conclude it here only. In the next lecture we will start with the different ways in which the polarization can be done by scattering, etc. So in this lecture we started, let me tell you the course progress. So introduction concept is being done, then the Huygens principle about the wavefront concept is being done, then the refraction and the reflection laws of light waves were being proved using the Huygens principle. Then the coherent and the incoherent addition of waves, we understood the concept of intensity, when it is maximum, when it is minimum. Then Doppler effect was also being understood in this concept only. Then next was interference of light waves in Young's experiment, in which we understood how the interference pattern are being observed, what is dark fringe, what is light fringe, what is dark fringe, what is bright fringe, etc. And finally we understood diffraction. What is diffraction? Nothing but bending of light. Is it a superposition of two diffraction pattern? Interference is a superposition of two diffraction patterns. And finally we are in polarization concept. So after polarization there will be a summary of the complete wave optics chapter, and that will be the end of wave optics. Thank you.